When we begin these adding and subtracting radical problems, they really aren't so bad. It starts off where we basically just need to figure out what the like terms are to combine. So in this case, just like we can only combine x with x, we can only combine something with root of 2 with something else with the root of 2. So we're going to treat each individual root number like it's a different variable x or y. In number 1, it says 6 root 7 plus 2 root 7. I need to see that as something like 6x plus 2x. 6x plus 2x would give me 8x. So in this case, 6 root 7 plus 2 root 7 gives me 8 root 7. So again, we're basically just treating the root as if it were a variable. For number 2, like terms are this 9 root 3 and this negative 5 root 3. This 14 root 2 and this 4 root 2. I can't combine something that has a root of 3 with a root of 2, but I can combine any of the roots of 3's together and any of the roots of 2's together. So 9 minus 5 leaves me with 4 roots of 3's. 14 plus 4 gives me 18 roots of 2. Same idea for number 3, except there's 3 different things I have to keep straight. Here I have roots of 5, here I have just whole numbers, and here I have roots of 7. So I can combine things that are like terms. I start with my roots of 5, 8 roots of 5 here, minus 11 roots of 5 there. 8 minus 11 gives me negative 3 roots of 5. If I now look at the roots of 7, here I have negative root of 7, which is an understood negative 1 root of 7. Here I have negative 9 roots of 7, negative 1 and negative 9 combine to give me negative 10 roots of 7. Finally, here I have plus 3, here I have plus 2, 3 plus 2 total to give me 5. For problems 4, 5, and 6, it's a little tougher because it doesn't look like they can be combined at first. Basically, we're going to have to put together what we did in 1, 2, and 3 with what we did in the previous class. Here we're going to have to break down these roots by simplifying them and see what's left over. Hopefully then they will be able to be combined. So when I look at 700 under a square root, I'm going to go and either get my paper handy or bring up on my computer my list of common squares and cubes. I try 144, it doesn't go in evenly. I try 121, it doesn't go in evenly. I try 100, and it does go in evenly. This breaks into the root of 100 times the root of 7. In these problems, if you get the first one correct, it makes the next one much easier. Basically, because I know this root of 7 is what was left behind, for these to be like terms, there also have to be a 7 left behind in the second. So what I can do is divide this 28 by 7, verify that I get a perfect square, and if I do, move forward knowing that it went right on the first one. So 28 divided by 7 gives me 4. I can break this into root 4 and root 7, and sure enough, root 4 does appear on my perfect squares list. So if I take this perfect square out, root 100 becomes 10 roots of 7. Root 4 becomes 2 roots of 7. Now I can just say 10x plus 2x gives me 12x, or in this case, 12 roots of 7. Same idea for number 5. Here at 75, I start by trying 64, doesn't work. 49 doesn't work. Then I get to 36, which doesn't work. And finally, 25 does go in evenly. It goes in root 25 times root of 3. Now that I've established root 3 is what's going to be left over, I can see if root 3 goes into this. It does. I can break root 12 into the root of 4 times root of 3, and this is a perfect square that would come out. So root 25 becomes 5 root of 3's, minus root 4 becomes 2 root 3's. 5 minus 2 leaves me with 3 root 3's. Finally, for the last one here, when I have the root of 245, I started 144 doesn't work, 121 doesn't work, 100 doesn't work, 81 times 3 gives me 243, but that's not what I'm looking for. 64 times 4 is close. No, that doesn't work. 49 does go in evenly. It breaks it into the root of 49 times the root of 5. Here I can see the root of 5 was left over. I'm going to keep that in mind as I look at the next two. If I divide this one by 5, sure enough, it leaves me the perfect square, specifically root 4 times root 5. Same idea, if I divide 125 by 5, sure enough, it leaves me the perfect square, root 25 times root 5. Now I'm going to take these perfect squares out. Root 49 becomes 7 roots of 5. Minus root 4 becomes minus 2 roots of 5. Plus root 25 gives me plus 5 roots of 5. Final step is just do what we did at the top of the page. Combine like terms. 7 minus 2 gives me 5. Plus 5 gives me 10 roots of 5.